Hello everyone and welcome to another video. I am finally at my desktop once again, and I've been working on cleaning up everything we did on the past 32 videos, and adding support for the Microsoft native C compiler. Okay, and I'm very excited because I was finally able to compile everything that we need, and basically it is working. So I'm currently using these native tools right from Windows, um, and basically I created these two batch files. So one for the client and one for the server. Maybe I'll just convert this into the not maybe, but I will actually convert this into the build executable we have. But this is just for testing for now. Because it has been hard to actually be able to compile all of these. But basically, we just create the folder, this build folder we already had previously. We delete all of the object files if they exist. Then we collect all of the source files, the C source files. And then we have this command that took me quite a while to develop. But basically this FE is the output name. This FO is the folder that is going to contain the .object files. Then this stuff is for warnings and stuff. I'm not really sure. I just copy pasted it, but I think it's for warnings. We also have like WX or something like that, but I'm going to keep it like W4 for now. This is normally include. Empty is, man, I forgot what empty is. It's like something threaded. Is multi. It's like static threaded something, like to basically to tell the linker to statically link with threaded mode or something like that. I can check that later and I can tell you. But then we put the sources we collected, we link, we need to specify the machine. This is x64 machine. Then the lib path, I just created another folder that in third party. So this is the min.gw thingy that I'm used to. Like I'm used to Linux utilities, and I generally, if I have to use a Windows machine, I generally just use Linux things there, right? I have general things like min.gw. They kind of bundle a lot of stuff like shell, Fortran compilers, and all of the good stuff, curl and stuff like that. So it's very easy for me to use min.gw because I'm used to it. So it was harder, but basically I created this MSVC x8664 folder. It follows the same idea, like right? It just has this dot instead of these archive files, it has these .lib files. It's basically the same thing for Windows, statically compiled lib, right? So it doesn't have like dynamic dependencies. It depends on the kernel, but yeah. And then we have all of these massive amount of libs, and if you guys are doing the same thing as I did, from min.gw to MSVC, I needed to add this shell32, I believe, and this MSVCRT lib. Okay, and that's for raylib. So if I go to build, you can see that I don't have like that shell stuff, right? For raylib, for min.gw, I only use LGDI32 and WinMN, but for MSVC, I had to use all of that stuff. So kernel, OpenGL32, user32, shell32. I really needed to add a lot of libs for this to work. And then for libuv, the only change I need to do from what we used for min.gw, so we already used this WS232 and all of that stuff. I just needed to add this advapi32.lib, and everything else seems to be the same, right? And then after that, we just check the error, and we once again delete all of the object files if they exist, because this native compiler, CL compiler, generates a lot of object files. And this is working, so I can show you. I can compile both. So here I can compile a client first, and this is going to do a lot of stuff. There are still some warnings, I believe. Yeah, there's some. I need to take a look into these warnings, so I don't have like any real issue with Microsoft compiler, but they don't seem to be that problematic. It's like more of types and stuff like that. So that's working for the clients, right? It's at least it's compiling for the clients. And then we also have this server, and I can show you. Okay, but I can do that. Okay, so it worked, right? So here we are running the server. It's super fast, right? It's super fast. And here I can run the client. So here is the client. I have too many windows open. Okay, so this is the server and this is the client. I want to show you something. So here, this is very interesting. I'm going to show you later, but as you can see, the client is working, no problem. Good amount of FPSs, everything is just fine. Okay, no issue rendering with Raylib. The map was loaded correctly, right? So there is literally no issue. Okay, cool. So I can shut up. Let me restart the client because I want to show you something interesting. Okay, so this is the same client. I don't know if you guys remember from the previous episodes, but basically, when we use MinGW, right? Basically we are using TCP, right? We are using just default TCP with whatever configuration libviv gives it, right? But this is very interesting because when we use MinGW, TCP with MinGW kind of bundles all of the bytes we want to send, and it sends like 64 kilobyte chunks, right? So it sends a lot of data at once. But Windows with the C-native compiler works a little bit different, right? So the libs are a bit different and the behavior is a bit different. It still works, right? But it's very interesting because now this is basically receiving many chunks of data, but smaller chunks. So with MinGW, we receive 4 64 kilobyte chunks, but with MSVC, we receive like probably 100 chunks, but each chunk is like 1 kilobyte or something like that, right? It never exceeds like 1.7 kilobytes, and not too much than that, to be honest. So probably the limit is around there. So the TCP behavior is a bit different between the two compilers, and basically because the compilers are using like different libs, right? So MinGW is probably using some port from Linux, and the Windows C-native compiler is probably using some port is actually using the native Windows libs, right? So I realize that, and it's a very interesting change, right? I prefer the Windows to be honest, because this is a game and I want to receive packages. I don't want to have buffering, right? So I don't want the server to wait for like larger packages to send them. I want to receive them as they are being sent, and this is better for gaming in my opinion. So the Windows wins in this specific case, but it's a lot more painful to compile something on Windows than it is on Linux, right? But yeah, so we are supporting both things, Linux and Windows, no problem. Okay, now I need to show you what I had to do for that to work, right? It was not easy, right? This was mainly copy paste, and I had to more or less understand how CL works, right? And all of these little flags that sometimes I no longer remember what they mean. But the most painful thing I had to do is to compile libuv from scratch using MSVC as well, so the native compiler from Windows. And until I found how that was meant to work, it was actually quite challenging, right? And basically I can show you what I had to do. So first, I wanted to compile libuv statically, right? I don't want to depend on DLLs or stuff like that. I want to have my libuv.lib file inside the MSV folder, and it's just meant to work, right? It just depends on the kernel, nothing else. So to configure that, I had to do -d, and then this specific flag, build shared libs, I had to put it to off, right? So I had to run that, and this is now going to configure the CMake stuff, right? I usually don't use CMake, I prefer to use shell, just easier. But yeah, so this configures that, and then I had to basically, where is it? Let me go back. Okay, then I wanted to build libuv in release mode, right? I don't want like to have an inefficient lib, right? I don't need debug mode for anything in libuv. So I basically had to do cmake --build --config, and then put release in front of it, and then this is going to actually build the release mode, the release build. So, and this is going to place it inside this folder, build, release, and then this is the correct file we need to use, okay? Because I was using files from vcpkg and files from winget and stuff like that, and all of those weird package managers. But the thing is that they would have this .lib file, so this libuv.lib, but this was not a static file. It had the same name, but it actually depended on DLLs. So it was quite painful to understand that, right? So and the difference is big. Like this is 730 kilobytes, and the other libuv files that the package managers downloaded, it was like 30 kilobytes or something. So the file size is also an indicative of that, right? And now we basically have I can go to here. So we basically just depend on these two libs, and I don't think I'm going to add any other dependency. So relib is just for graphical stuff, and libuv is for networking. Just that, okay? We don't need anything else. And I'm using relib and libuv specifically not because I don't want or I don't know how to use Windows specific stuff, but because I want to have a multi-platform game, and I don't want to implement specific functions for every single platform, right? And even for Linux now we have X11 and Wayland, and even I was trying to install Fedora 40 yesterday on my broken laptop. I just recycled it, and it's now a Linux machine. And Wayland doesn't work with, at least the specific version I'm using doesn't work very well with a GTX 1050, a Max-Q graphics card. Like the new NVIDIA drivers that actually work, that are proprietary, people say, and from my experience, they actually only work from RTX models above that. So older GTX models, they still don't work very well. And yeah, I can agree. I had a very bad experience. So I'm probably going to go back to X11 instead of Wayland for this specific Fedora KDE Plasma. And yeah, so with all of these like different ways of doing things, I think that really is more than a good choice, right? And the same thing for libuv, right? In libuv, it's already pretty efficient. It uses I/O U-rings for both Linux and Windows, right? So it's a very efficient way of doing networking and file accesses and all of that. And it's a very decent lib, right? It supports, it scales very well. So we only have basically, so this is 5 mega, more or less, yeah, about 6 megabytes of libs for Windows, and for Linux we have about 2.5 megabytes, right? So this is the big difference. As you can see, like Windows stuff requires more data in general. But yeah, but the executables, to be honest, so we can take a look at the executables. So the executables for Windows, we can put something like this. So for Windows native, the client is just, and this is the entire game, right? This is the entire game. We don't depend on anything else. The executable is just the game itself. We don't have assets, external assets or anything like that, right? So this is 631 kilobytes. And for this server, we only have 88 kilobytes. So it's very, very compact, right? We still require a lot of development, but it's quite compact. And now we can try to run the MinGW version. For that I need to open my development kit. By the way, this is the development kit I usually use on Windows. It's great. It's W64 dev kit. It has a bunch of stuff, like everything you need. GCC, G++, like if you want Fortran, it has Fortran. It has a bunch of, it has grep, right? Where is it? Yeah, it has grep, get opt. It has a bunch of stuff from Linux. It's a great port. It's a great bundle. It uses MinGW stuff. It's fantastic, right? And I just launch this console and I have access to everything inside this development kit, inside this console, right? So if we open Dear Universe once again and we execute the build script now, I don't have anything running, do I? No. Yeah, I think it's fine. Okay. So if we build developments clients, this takes a little bit longer to build, to be honest. Like this MinGW compiler, it's slightly slower, but let's see what is the file size. So now the client is 1440 kilobytes, right? And the server, we need to build it, so we can just say development server. And the server is now 403 kilobytes, right? So MinGW requires libs.a file, so archive files that are smaller, but the final executable is larger. And MSVC, so the native Windows compiler, requires .lib files, so static libs that are much larger in size, but the final executable is smaller. So yeah, I guess that's something to take into account. Like both are fine, right? I don't know, if I ever ship a game, I can probably ship both versions. We are going to support both of this stuff. I still need to test this compilation on native Linux. I'm probably going to use my Fedora machine to test it, but yeah, it's just fine, right? It's nothing too concerning. Okay, and that's basically everything in terms of compilation, right? So I'm porting, is still not complete, but I'm porting the compilation to support both MinGW and MSVC. Both are being supported right now, and everything is working, okay? And I also restructured the folder like I said I would. So now we basically this is a root. We only have apps, build, and third party. Apps is for the apps of the project. Build is for the build, the results of the build thingies, right? So this is where the object files go, and the executable files and .out files and stuff like that. And then I have third party that contains the platform specific libs and the header files, right? And that's everything, right? That's entire project. You already know what third party does. You already know what build does. This add more changes because now we basically have currently we have three apps: the build.c app, and this application is meant to build the other applications. We have client.c, it's the same thing, and server.c is the same thing that you are used to, right? So each specific app has its own folder, right, with its own stuff, and we have an extra folder called shared that has all of the shared header and source files for the apps, basically. I already finished the port from the C23 to C99, so basically we have the same thing. The pool, I went with a slightly different architecture. I basically used basically I just used dynamic sized blocks, and here I have an array of used blocks and unused blocks, and then I just push and pop from one and the other as they are being used, basically, right? Nothing special. Arena is exactly the same. I didn't change the arena implementation. I just, instead of being a linked list, I just made it an array, right? And everything else is the same, right? Same implementation. Just a port from C23 to C99. Then I had to remove the dependency from relieve, so I implemented my own structures for colors and vector tools and rectangles. Nothing special. The code is exactly the same, just changes the variable, the type name. Here on math.age is where I place these types that are needed for this actually doesn't need to be like that. Okay, that are needed to not depend on relieve directly, right? Slice is exactly the same. I just added this macro slice remove. It just removes an index from the array using memcopy. Super simple, nothing special as well. And then solid is also the same. So shared folder is pretty much the same with some added features, and I finished the port from C23 to C29. Server, same stuff. I didn't change anything. I literally, it's the same code, right? Just change this type, right? Type name. Then the clients add the most changes. Here we are going to see transport and worker. I'm going to explain that later. And we have state. State is going to hold the state, basically. Now we don't, the state of the game does not depend on relieve directly, because we are using our own structures. This is because libv and relieve, they have name collisions. But yeah, everything is working, right? And the source file just creates this variable, right? Then we have this screens folder, same as scenes, right? I just made a small change. So now I've created this screen function, and it's basically a function pointer that implements, well, I can do something like that, yeah. That has this structure as an input function, update and draw, and then each source file implements its own structure, and we have currently only the screen loading and screen playing. Playing is the same thing, right? Instead of having like those procedures that we had previously, we just export these variable with the correct functions, right? And we have this as static, so it's only used by this compilation unit. Loading is the previous connecting, just name change, and I just put screen loading instead of having the procedures exported. I just export this variable. Okay, super simple. And here the state is going to always hold the current screen, so it holds that, basically it holds that structure. And in the worker.c, we, instead of having like that switch statement, we just called the function pointer directly. So also super simple. So yeah, the worker is basically init, input, update, draw, and close. Okay, transport is a previous network, same code, doesn't change anything. Instead of calling like those functions, I don't know if you remember, like to set the terrain stuff and things like that, we just use the state directly, because now the state is independent of relieve, and we can use the state across the entire code base. It doesn't matter. So the state is a separate module from the work. So workers and states are not the same thing, they are separate modules. So here, instead of calling a worker function or the previous app set whatever function, we'll just use memcopy directly, and everything is fine. And here, instead of updating the state by that enum, we just set the screen to the correct variable we want, and everything works, right? It's so much simpler, a lot better. So I still need to clean up a lot of stuff, but it's getting a lot better, right? So this cleanup, it's much better, much better. Okay, so I'm going to explain you. I basically with this, by cleaning up all of this code, I came up with the architecture I'm going to go with, basically until release, I believe. If I'm not really predicting to have much changes in terms of architecture, because by cleaning up all of the code I've built in these 32 episodes, like the architecture of this game started to emerge naturally, right? And I just started to give names to stuff. So I can go to Paint, and I can explain you the architecture of this game. On one side, we are going to have the server, right? And on the other, we are going to have the clients. Okay. So we can say that this is the server. Can actually increase that. Okay, cool. And this is the client, right? For now, I still have the idea of having a server single threaded, right? So the server is going to have a single thread. I can use probably pencil now. Can I change the size of the pencil, or probably not? Okay. So basically the server is going to have a single thread, right? It's going to be single threaded. And this is basically the main thread, right? Nothing special. And it's going to be responsible by handling map updates and network communication, right? The transport layer and stuff like that. So nothing special. So a single thread for everything. The client, as I already had previously mentioned, or it was basically the architecture that was emerging from what I was coding. The client is going to be dual threaded. So instead to have two threads, right? It's going to have the transport thread, and this is what you saw on that C file. So this is a transport thread, right? I call it transport, and that is going to have the worker thread, right? And the worker thread is basically going to do all the work that in terms of like simulation, graphics, and stuff like that, right? Okay, I think it's pretty explicit. And then we are going to have a module that is not a thread, it's just a state, right? So the state is going to be shared across both threads, and this is the global. Actually, I can call it global. So this is the global state is going to be used by both threads. We will try to not have any race condition, but in theory that's not going to be a problem following the architecture I'm thinking about, right? So the worker is going to talk to the transport layer to send updates. So let's say a user like changed this velocity, right? So it was moving to the right and it's now moving to the left. The worker thread is going to inform the transport thread, look, the user just changed this direction, and the worker thread is going to queue that event, and then it's going to send that event to the server, right? The server is going to send other user updates and map updates and stuff like that to the client, directly to the transport thread, and the transport thread is directly going to, this is actually like so, right? Is directly going to update the global state, okay? So the the transport thread is never going to talk to the worker thread, never. It just updates the global state. And the worker thread is going to both read and write from the global state, basically, right? So super simple. So this is write only, this is read and write, this is write only, and this is read and write, right? So this should in theory not have any like problems with race conditions as long as we are careful with the things we do. But this is basically the architecture I'm going to use for this game, right? As you know, I think I already was I think I already mentioned it. This game is going to be an MMO, sandbox survival MMO. Like, it's going to be interesting. So in theory, I'm expecting to be able to support at least 300 players, right? Probably more. Okay, this is my goal, 300, right? Yeah, the client has two threads. It basically updates on block the main thread, so in terms of FPSs, you are not really going to have any issue, I think. And for the clients, I want to support basically Windows XP Plus. So I want to support everything from Windows XP to like Windows 11 currently, right? So I want everything from there. I want to support Linux, right? I'm gonna see how this behaves with older NVIDIA graphics. I'm going to use my old broken laptop to do all of those tests. But yeah, I want to support Linux both in theory, if preferably both X11 and Waylands, right? And I want to support macOS, right? I know that macOS deprecated OpenGL, but it still works, right? So it's not problematic. Relive is still going to work, and Relive, I think it can use the Vulkan backend and stuff like that in theory, or maybe not. Yeah, it in theory it can use Vulkan backend because it already supports SDL2 backend, and SDL2 supports Vulkan, if I'm not mistaken. Maybe I'm wrong, but I think you can try to do something like that. And I think that's basically so. Right now I want to support the major desktop environments, right? Linux, Windows, and macOS. And probably FreeBSD, right? It's probably also easy to support FreeBSD, and I think that's it, right? I'm still thinking about like web. I'm probably not going to support web. I could support web very easily. It's super easy to compile Relive and libviv to web from what I was able to see. But I need to think about if that is actually applicable to the kind of game I want to have. I need to think about it, right? But for now, I want to support basically have a client that works on basically any of these desktops, right? So very old Windows versions up to modern ones, 32-bit and 64-bit, and Linux, macOS, FreeBSD, and stuff like that, right? For the server only needs to be supported on Windows, right? Slash Linux. And I can probably say 64-bit, right? I don't really need anything more than that. And why do I need to support Windows? Well, I really don't know. I just want to see the behavior of the server, if it has a change, to be honest with you. If the maximum player count of the server, so when the server starts to bottleneck, if it bottlenecks with a different amount of players on Windows or on Linux, right? So I want to compare both OSs and see how they behave with this kind of load, right? Otherwise, I would just support Linux and everything would be fine, right? But yeah, I think this is more or less the architecture I'm going for. Yeah, and from now on, we are going to fit our development within these restrictions. So we are not going to be like so drafty in the episodes, right? We still going to write sketches from now and on, from time to time, but we'll try to stick to it, right, to this architecture. Yeah, so those are basically updates. We now support native Windows, MinGW, and I still want to test at least Fedora 40 or Debian. Debian 12, I think, is the latest release. One of those, and then I can say that I also support Linux, right? Until then, I cannot say that I support Linux. But yeah, that's everything for today. Thank you for watching, and I see you in the next one.